The idea of automating packet analysis is quite attractive. We often capture very large amounts of data with Wireshark and in particular with DumpCap, and it's really useful to be able to do some initial analysis in a programmatic way rather than actually trawling through the files with Wireshark. We perform the automated packet analysis just simply to check the quality of the data that we've collected. In particular, do we see the actual traffic that we expect? Have we got lots of dropped packets, so the capture didn't work very well and we've dropped a lot of packets? Have we set up the capture in a way that's caused lots of duplicates, which is quite easy to do actually in some circumstances? So all of these things, we'd like to eliminate those before we dive in and do some really detailed analysis. So the purpose of this presentation is to look at the use of SharkD, which is an executable that's part of the Wireshark suite, although we'll discuss later that it's not actually shipped in the binary. But we'll look at SharkD, and we'll also look at using Python to execute programs that manipulate data using SharkD. Okay, so the agenda today, we're going to look at the objectives. Why would we want to do this? We'll look at the capabilities of SharkD. SharkD runs in one of two modes, console mode and daemon mode, and I'll explain those. We can access SharkD using JSON style API calls, and we'll take a look at those. Then I'll show you an experimental Python program that I've been playing with. We'll look at the installation of SharkD, because as I said, it's not actually part of the binary package that's shipped. And then we'll look at some documentation. So SharkD has a whole bunch of methods that you see listed here on the right, but you can group them together into the ability to load a file, to configure SharkD and Wireshark, basically all of the Wireshark libraries in whichever way you want, to perform filtering against the loaded file, and to analyze the file. We can also output the full details of a single frame, or we can output data that's very similar to exporting the packet list columns from Wireshark. We can also output statistics information and entire objects such as an image file or even just an HTML file, just in the same way that you can export objects out of Wireshark. So you can pretty much do everything you can do in Wireshark by sending commands to the SharkD interface. SharkD will run in two different modes. We can run it in console mode, in which case we just fire up the program and then start sending JSON style commands to it, and we get responses. Or we can run it as a daemon, basically as a TCP based service, and obviously this is the most useful way to run it, because then we can communicate with it. We can communicate with SharkD using another program. So I have this small experimental program, and it just creates a TCP connection to SharkD and then starts sending commands and getting responses. And a very simple command shown here is how we load up a trace file and the response we get once the file is loaded. Because SharkD is using all of the Wireshark libraries, DLLs, that Wireshark itself uses, then it supports all of the protocol decodes that you find in Wireshark, but it also supports all of the trace file formats, so PCAPNG obviously, but also TCP dump and Snoop and all the other things that you know and love with Wireshark. Let's dive in with a demonstration. I'm going to start by looking at SharkD in console mode. So we can start SharkD in console mode just with this command. In fact, I think we have to do it like this, and this hello in child prompt is actually telling us that SharkD is now running. Now I'm going to go to a file that I have that has just a few ready formatted commands, because obviously I don't want you to have to watch me typing in commands. So let's start by loading up a trace file. So you can see that loaded fairly quickly, and now we have the trace file loaded. We can list the contents of the trace file. I'm only going to list 2 frames of it, but basically we can do what's the equivalent of the packet list display in Wireshark. So you can see we have some responses here, and in this case we have I know it's quite difficult to make this out, but basically we have a SYN followed by a SYNAC, which are the first 2 frames in this particular trace file. Other things we can do is we can actually look at the detail for a particular frame, so we can display all of the information for a frame. So if I put that in there, and I didn't do that correctly, let's do that again. And this is just summary information, as you can see. Let me just put in the additional piece of information. I think it's proto : true. Whoops, there we go. So this is every single field from that first frame in my packet, all dumped out for us, and so we can process that. And if you're used to Python, using Python, you'll know that loading JSON in as a Python structure is really simple, because there are some great Python utilities to do it. So let's now move on to actually running this as a daemon. Okay, I think what I should do is clear my screen first. Whoops, because I'm still in the program. Let's get rid of that lot. And you can see that I did run this earlier. So now we have it running as a daemon, and I can use something like PuTTY to communicate with it. So let's connect to it with PuTTY. In this case it doesn't give the hello child prompt. Don't be off put by that, it's actually working. Now we grab our command and paste it in here. Let's actually change the configuration here a bit so you can see it a bit more easily. Okay, so we'll do that. One of the strange things, differences between running it in console mode and running it in daemon mode is, in console mode sometimes it throws out sort of other messages between the JSON request and response. And in this case, when you perform this particular request, loading a file, in console mode it will actually throw out another message in between. But in this remote mode, in this daemon mode, you don't get that. So, but everything else works just the same. So, for example, let's do the frame list one that we did before, the packet list one. So just the same stuff, and I can do the frame detail one as well. So that's one way you can just mess around with it and just check that it's working correctly. The next thing I'm going to do is I'm going to leave this running in daemon mode, but I'm going to come into here, and I have this program. I'll show you the program in a second, but let's just run the program initially just to see what we have. Now this takes a while to run, so I'll skip forward in the video once this is complete, and then we'll review the output. Okay, so that's now complete, so let's wind back a bit and go through the actual output. So what I've done is I've written a program. It starts off just by printing out the sort of summary information you'd expect at the start of this type of report. You notice that during the capture we've missed 40 packets, and the way it's detected this is it's looked for entries in the trace file where Wireshark has added an expert comment that says that the previous segment was missing, and that's always a good indication to tell you that you've missed some packets. It's not that you've had a retransmission, because you wouldn't get that error, but it does tell you that you've missed some packets during your capture. Then we've dumped out all of the service endpoints. So here are all the servers and all the corresponding services, and you can see we've got a lot of Citrix ICA stuff here, quite a few websites, yeah, whole range of different services dumped out for us. Then, oh, by the way, I did that just with the conversations method that you can use in SharkD. So you can just request conversations, and then I just pick the information out of that. Then we go on to this one which gives root stability. What I've attempted to do here is look at how constant the TTL value is for packets that are going past my trace point, and where we see this variation, that is a good sign of instability. Now, we've got some really strange numbers in here, I have to say, and I do know the cause of some of them. I know one of the reasons was that a number of the systems were behind a load balancer, and the time to live value on each server sitting behind the load balancer was set differently, and I think that's why we get these 31 and 63 numbers, because some of them were set to 32 and some were set to 64, and so depending on which server responded, that's why, and they're all going to appear to come from a single address, that's why we were getting a large variation. But we do see some variation here that looks as though it could be a bit suspicious. So we've got 254 versus 255, etc. And there were some network stability issues with this trace. The other thing is, if you look through it too carefully, you'll think, well, how can I possibly have some of these numbers on devices that seem to be on the same subnet? Don't get too hung up on that. I anonymised the trace, and I may have messed up the anonymisation, so that's probably why they're like that. Okay, then we come into excessive retransmissions. We don't have any retransmissions, which was quite nice to see, but we did have lots of dupacks. In fact, we had so many that we had 105, so you can see it shows the first 5 and then the last 5, and that's just a function of the way that I've written the Python code, which I'll show you in a sec. 2 DNS servers involved. Most requests were going to this second one. We didn't see any DNS requests with missing responses. I've got to work on the service errors thing, so that's not been done. But here we've got some useful information about DNS request latency, so the response time from the DNS server. And then we go on to look at response time from all the services. Some of these, this is all done using Transum, and using Transum against Citrix ICA traffic is a complete nonsense. So a lot of these numbers we can ignore, but it's useful stuff to see. And finally, we've got this thing down the bottom, which actually, although it's a very simple thing, is really useful. If you go and look at a trace file with Transum, you often have to keep looking at which conversations you're interested in, and then plug another TCP port number into the Transum configuration, and then you'll find you're missing another one. Well, with this, you can simply mouse over this, grab the lot, and then paste it in to your Transum preferences. Some of these I would definitely drop, like 1494, obviously, and 445 is already covered it for another reason in Transum, so you wouldn't do that one. And we've got others in here which are completely nonsensical, like 2000. There's a lot of Cisco skinny digital voice, voice over IP traffic in this trace, and I think 2000 had something to do with the media streaming aspect of that, so that can probably be ignored, and so it goes on. But it gives you an idea of exactly what's going on. So that's the output from the program. Let's look at the program itself. I'm not going to slog right the way through this in a great deal of detail. I'll tell you how to get the code if you want to play with this, because this is just an experiment, but you're quite welcome to play with it. What I have done is I've broken the code up into 3 chunks. This is the code that basically makes the decisions about what we want to do. But I've tried to simplify access to the data by providing a first tier of sort of function calls. So like get the DNS information and get the frames information and get detail for a certain frame, etc. And get conversations, as you can see. And then the tier above that, or below it, whichever way you want to look at it, is actually accessing the data. And I've done quite a lot of work to make this as simple as possible. One thing I've done which I'm quite pleased with is you can specify just a list of columns in the frame. When you do get frames, you specify all the Wireshark fields you want, and this code will automatically set all the data types correctly in the return data, which is, I know that might not seem a big deal to you, but that was quite a big thing. You do have to do a quick initialization of the columns, and you'll see how that's done once you start to look at this data. But it's this thing here, data access init schemas. As you can see, you don't do much. You just pass it the list of columns, and then the code goes and queries all of the properties of all of those columns from SharkD, gets all the field types back, and then stores those for later parsing out the data as it returns for each frame request. So that's pretty useful. Certainly made it easier for me to write more code. So installing SharkD. So SharkD was included in the installation packages in the past, but it's no longer included. So you have to build it from source. What's more, the version of SharkD that I'm using is actually based on code that I've submitted to the project, and I'm waiting to be merged into the master tree. So what you have to do is you'll have to pull Wireshark master and then just grab a single file from this location and copy that over the existing file and then do your build. But I would advise you to build from source the first time to check everything's okay, and then move on and just replace that file and build again. And then everything will work. You can mess around with the previous version of SharkD. You'll just have to modify the code that I've written to work with the existing SharkD API. The reason that I rewrote this was because the SharkD API is good, but it's not very consistent and it's quite difficult to work with. Sometimes it doesn't give a response to certain types of method call. So it's now been rewritten to conform to the JSON RPC standard. That's not to decry the work of I think it's Jacob who did the original work on the on SharkD, because it's a phenomenal piece of work, quite honestly. I wouldn't have wanted to take it on. It's a big job. So you can download the Python code from here. That experimental code that I've been playing with, you're quite welcome to take a copy of that. Documentation. I've done quite a lot of work on the documentation, both for the original version of SharkD and this new version. So you should find that really useful. You'll find two different pages in the new Wireshark wiki. There's one which is the overview page, so I'll show you that overview page. So here's the overview page, and it tells you all about running SharkD, startup parameters, the general format of the requests, and then a sort of summary of all the different requests that you can send it. How to mess around with SharkD using PuTTY, and this is another very simple, as you can see, it's only 50 lines of code. Another bit of simple coding that you can use to mess around with it, just to check how it works. That's the overview. If you go to one of these, if you click on one of these, it will take you to the actual detail page where I've broken down all of the inputs and outputs for every type of request. So that's available to you. If you want the original version, I haven't put any links in here, but if you just go up here and knock off the JSON RPC off of the end of the URL, just to prove me wrong. Let's go here and do it this way. Shark D. You can see there's this one. And so that's this gives you the same information but for the original format of command. You might find that useful if you want to use the format of Shark D without my modifications, which have yet to be merged. If you want to keep an eye on my stuff being merged, this is the merge request 2309 in the Shark D. In the Wireshark repository. The problem with merging, the reason it hasn't been, well, it may be rejected of course, but one of the reasons it takes some time to get it to merge is because the core developers have to review my code, and I wrote quite a lot of code for this, so it's quite a big job, and so they're probably deciding how they're going to handle it. Here's the page from my GitHub repository that's got the code in it. So you can experiment with PuTTY, you see the guide. And my final closing comment is Network Datapedia. It's where all the real Wireshark specialists hang out. The Chris Greers and Tony Fortunatos and all these people. I noticed Betty Du Bois has just put an interesting article on the site. So please do check out Network Datapedia. Okay, that's it. Hope you found that useful, and I hope to speak to you soon.